Alright, finishing up these formulas here, shear wave formulas. We went ahead and said we did before the V path, the one leg, and the skip distance. Now what we're saying is we figured out the V path, we figured out one leg, we figured out the skip distance. We want to know if we have a reflector in here somewhere, where is it going to be? Or where or how can we see it? Okay? So let's just put up an A-scan screen here, just a small one. Here's 0, here's 10 inches. In this case, we're still using the same part we had before, 1 inch thick plate, so on and so forth, 70-degree transducer. So if we have a reflector just happen to show up at 5 inches, we want to know what is the depth and what is the surface distance over to that defect. Okay, and as we can see here, we've got a surface distance of 4.69 and we have a depth of 1.71. Now remember, we only have a plate that's 1 inch thick, so we're going to have to come back and deal with this in just a minute. So, reflector at 5 inches, we have a surface distance of 4.69 and a depth of 1.71. So if we come over here now and take a look at this drawing, there's our drawing that we had before. I went ahead and put a reflector at 5 inches. I just put here from 0 to 2.92, roughly 3 is going to be leg 1. Leg 2 is just going to be just past that to 5.84. We shoved a reflector in there of some kind at 5 inches. It doesn't matter what it is, and it really doesn't matter anywhere where it is because we can triangulate where the depth is and so on and so forth. Anyways, so sound's coming out of the transducer, bounces at the bottom of the plate, headed back towards the top. We hit a reflector over here at 5 inches on our sound path distance, which if we roll back over here, that would be 5 inches on our A-scan screen, which you see right there. So now we need to go back over here and kind of back out a little bit so we can get the best of both worlds and say that if we have a reflector of 5 inches shown up on our A-scan screen, we already know that it's in leg 2. Okay, we already know it's in leg 2. So if we're going to look at this at reflector 5 inches deep, we're going to say, since we've already figured the surface distance, the sound path distance times the sine of the angle, sound path distance of 5 inches, sine is 70 degrees, that gave us 4.69 inches. So we would measure from here, right at the beam exit point of the transducer, 5.5 inches out, okay, straight across the surface of the plate, right there, make a mark on the top of our plate, or something that we could say, alright, straight down from here is our defect. Now, we come back over here and say, what's the depth? Okay, sound path distance times the cosine of the angle. 5 inches times the cosine of 70. And that tells us, alright, it's 1.71 deep. So that means if we came over here, 4.69 inches, I said 5.5 earlier, 4.69 inches, straight over to here, let's write that up there, 4.69 inches from right here to right here. If we came over 4.69 inches, so 4.7 inches, and went straight down 1.71, that would be where our defect is. Well, we know that's not possible because the plate's only 1 inch thick, like we said before. So if the plate's only 1 inch thick, we need to start subtracting out the thickness of this plate, because when we're traveling down here, okay, as that sound is coming down in leg 1, we measure from the top of the plate down for any defect. Okay? Now, as that leg comes down here and bounces and send it back up, we are actually measuring from the top of the plate up. Or sorry, from the bottom of the plate up to that defect. So, we come back over here to our 1.71 inches deep. Let's get over here, zoomed in a little bit. So we come over here to our 1.71 inches deep, and we say, alright, the depth of the reflector is 1.71, but our plate's only 1 inch. Alright? So we subtract out a plate thickness, and that tells us it's 0.71 inches deep. But remember, the sound bounced and is coming back up, so all that information is coming from the bottom up. So really it's telling us that this 0.71 is from the bottom of the plate down here up to that reflector right there. So we want to know from the top down, if this was the top of our plate, from the top down, where's that defect? So we subtract out an inch again. Alright? And that's going to tell us that from the top down, that defect is actually 0.29 inches deep. Alright? Let that soak in for just a second. Then we'll go back around here to our picture. Take a look at our picture. Right over there. So before, we said that our reflector was 1.71 deep, which would put it down here, so we subtracted out a part thickness. That told us that from here to here was 0.71, so from here to here, I know I got a bunch of stuff happening here, so if we get rid of a lot of this, from here to here now is actually 0.29 inches deep. Okay, 3/10 of an inch deep. So, when you're measuring from leg 1, 3, 5, 7, it's always going to be from the top down for the depth. When you're measuring in leg 2, 4, 6, 8, so on and so forth, you're going to have to subtract out the part thickness until you get down to something less than what your part thickness actually is. And then that measurement is going to be from the bottom of the plate up. Okay? So to get your actual measurements, you're going to have to be subtracting out the part thickness again to get from the top of the plate down.